Okay, dear engineering students and the students aspiring to sit for GATE 2021 in mechanical engineering. Uh, Let us move on to engineering mechanics and solve another good numerical. That is problem set 2. This is the problem of problem set 2.1, solution to 2.11. By doing this, you will be very comfortable how to resolve a vector into two components. A given vector in any direction, how to break it into two components, right? So actually, very nicely presented by Professor D.H. Young, Professor S. Timoshenko, Director J.V. Rao, and Sukumar Pati in the book called Engineering Mechanics, Tata McGraw-Hill publication of 5th edition. So let me begin. The statement of the problem is like this, very simple. Resolve the force into rectangular components. Rectangular components means if this is one component and another component is like this, then and the angle is 90, then you say these two components are rectangular. One can be like this, the other can be like this. One can be like this, the other can be like this. One can be like this. From this point, the other will be into the plane of the paper. Means whenever the angle between the two components is 90, then you say the two components are rectangular components. Actually, there are four diagrams, A, B, C, and D. In all the four diagrams, here as well as here, there is a given force at some orientation, at some direction, and the axes have been presented very nicely to test your ability to split the given vector to find out your ability to split the vector into two rectangular components. Now look, in the first one, this is your x-axis and this is your y-axis. When I say x-axis, from this point onwards is positive x-axis, and from this point downwards is negative axis. So this is your y-axis, positive y-axis. To this side there is no line drawn, so to this side is your negative y-axis. Similarly, in the second diagram figure, this side is positive x-axis. From this point upward is your negative axis, and this is your positive y-axis. So this will be your negative y-axis. Means only the positive x-axis and positive y-axis are shown dotted lines. Then you have to imagine where is the negative x-axis and negative y-axis. Similarly, here in the third one, from this point to this side is positive x-axis. From this point to this side is positive y-axis. Similarly, in the fourth one, from this point to right hand side horizontally is your positive x-axis. From this point vertically upward, not vertically upward, in this direction, this direction is your positive y-axis. So in this case, the negative x-axis is to this side, the negative y-axis is to this side. Similarly, in this case, the negative x-axis is to this side, the negative y-axis is to this side. Now, in all the four cases, a force is given. Look, here is a force making an angle alpha. Here is a force F making an angle alpha here with positive y-axis. This alpha is also with positive y-axis. Here, this is slightly tricky, not very tricky. This is the force. This angle is given is alpha. Here, this is your x-axis. This is your force. This angle is alpha. And I probably forgot something. Okay. Then this angle is beta. It is given. This is your force. This angle is beta. This is given. This is given in the question. And in all the four cases, in this case, in the first case, case A, case B, and in the diagram in the case C and case D, we have to resolve this force here, this force here, and this force here into rectangular components, means components along x-axis and y-axis. So let us begin with the first one. So I have redrawn this diagram. I have redrawn this diagram in the solution here. This diagram is same thing as this diagram. Let us break this force, split this force into two components. So now look, this is your force. This angle is given as alpha. This is positive x-axis, this is positive y-axis. So considering this F from 0 to C represented as F, and this angle is alpha, considering this force to this side as the diagonal of a parallelogram, then the parallelogram should be like this. From this point I draw a perpendicular on y-axis. From this point I draw a perpendicular on x-axis. So this one from O to B, this, which is same thing as from A to C, will be one component, and from O to A will be another component of this force F along y-axis. So this component will be positive, and this component, because it is along negative x-axis, so this will be negative. So in this triangle OCA, if you take cos alpha, it will be OA over the hypotenuse. And if you cross multiply, you get OA is equal to F cos alpha. OA, that is same thing as OC, is your F cos alpha, that is the y component of the force F. Now, in this triangle, if you take sin alpha, it will be a perpendicular over hypotenuse, that is AC over OC. OC is given as F, and if you cross multiply, you get AC, that is same thing as OB, that will be minus F sin alpha, because it is along the negative x-axis, therefore a minus sign is used. So this is your x component, this is your y component, right? Then coming back to the second one in the question here, positive y-axis, positive x-axis, this is the force F, this angle is alpha. Let us find the components of F, rectangular components, not components, rectangular components of F. So I have redrawn the diagram again for you here while solving. This is your positive y-axis, this is your positive x-axis, this is your force. So considering this OC, which is given as F, making an angle alpha with positive y-axis, from here I drop a perpendicular on positive x-axis. From here I draw a perpendicular on positive y-axis. Therefore, in this parallelogram, this is the diagonal, the resultant F. Therefore, this is one component and this is another component. OA is one component, OB is another component. Since this angle is alpha, so this will be F cos alpha. So your OA is your F cos alpha. Always remember, while finding the rectangular components, the side in front of the angle will always come in sine form, and the other one will always will always arrive at in cos form. So here if you take sin alpha, this will be this perpendicular by this hypotenuse. This perpendicular is same thing as OB. So OB over hypotenuse, which is equal to F. So if you cross multiply, you get OB is equal to F sin alpha. Both are positive because this OA is along positive y-axis. This OB is along positive x-axis. Therefore, both are positive. Now, then coming back to the third one. The third one. Positive x-axis, positive y-axis, this is the force F, this angle is alpha. Let us find the components of this force, rectangular components of this force F, not components, rectangular components. So I have redrawn the diagram for you again here. I have redrawn it. Positive x-axis, positive y-axis, this was your F, this angle was given as alpha. Very interesting. If this is alpha, then this will be 180 minus alpha, because this is a straight line. This total angle has to be 180 degrees. So if from this point to this point through this angle, if this angle is alpha, the remaining angle will be 180 minus alpha. Now look, this is the force F given. So to find the rectangular components, from this point I draw a perpendicular on y-axis, and from this point I draw a perpendicular. If you extend this line, it will be perpendicular to your x. If you extend this line, it will be perpendicular to x-axis. So OB is one component, OA is another component. Now this angle we have found it as 180 minus alpha. This line is parallel to y-axis. So if this angle is 180 minus alpha, this angle is also 180 minus alpha. So the two components of the force F, one component is this OA, the other component is this, and the angle between this component and this component is 90 degrees. Therefore, they are rectangular components. And if you look at the triangle OAC, this angle we have found out as 180 minus alpha. So if you take cos of this angle, it will be OA over OC, that is OA over F. And if you cross multiply, it will be OA is equal to F cos 180 minus alpha. Means the side adjacent to the angle will always come in terms of cos function. The force, the hypotenuse, times cos of that angle, and cos of 180 minus alpha is minus cos alpha. So this component OA is minus F cos alpha. OA is minus F cos alpha. Means positive y-axis is this way, and this one is opposite to the positive y-axis. Therefore, it is minus F cos alpha. That is what the meaning. So that is the y component. Now, this is the side in front of this angle. So I just explained the side in front of the angle will be hypotenuse times the sine of this angle. So if you take sine alpha, sine of this angle, sine 180 minus alpha will be perpendicular, that is AC over hypotenuse, that is F. And if you cross multiply, you get AC, that is same thing as OB, as F sine 180 minus alpha. Sine 180 minus alpha is sine alpha, and this thing is positive. Therefore, it is along positive x-axis. Look. So your OB is in the direction of a positive x-axis. Or you can shift this force. Like this. You can shift it like this, and then find the components. Right. So this will be same thing as OA. This will be same thing as OB. Fine. So now let us go to the last one. The last one, that is this one. Positive x-axis, positive y-axis. Here is a line, and this is the force. And this with this line makes an angle alpha with x-axis, and this is the force. We have to resolve this force into two rectangular components. Means its component along x-axis and its component along y-axis. So I have redrawn it in the solution. Now look here. This is your x-axis, this is your y-axis. This angle was alpha as given in the question. This is your force. From O to C is your force F. And this angle was given as beta in the question. Now look at this line. Look at this line and this x-axis. So means let me explain like this. This angle is alpha, this angle is beta. So this angle will be also alpha. Now I have to break this force F into two rectangular components. One component is OB, one component is OA. One component is OA. Since this line, which is along x-axis, therefore line OB, the component of the force F, is this one. OB is parallel to x-axis. So if this angle is alpha, there is a line here. Here is a parallel line, parallel to this. So if this angle is alpha, then this angle will also be alpha. So this angle is alpha, given this angle is beta. Therefore, this much angle will be alpha minus beta. This much angle will be alpha minus beta. So here we have a force. We have a force F. We have a force, I am redrawing for your convenience. We have a force F, which is making an angle alpha minus beta with the horizontal. Therefore, this component will be F of cos alpha minus beta, and this component, that is same thing as this, will be F of sin alpha minus beta. So, and this is along positive x-axis and this is along positive y-axis, therefore both are positive. So your OB, that is this one, that is same thing as this one. Now this point is C, is your F times cos alpha minus beta, that is the x component, it is positive because it is along positive x-axis. OA, from O to A, will be your F sin alpha minus beta, it is along positive y-axis, therefore is the y component. So I think you are clear about how to split a given vector into two rectangular components when there are different orientations of the axis. It will be very useful for you. Okay, thank you.